All right. Hi, everyone. Thank you for coming tonight. I'm Cassidy Westron. I'm the Public Programs Coordinator here at the List Visual Arts Center. We're here tonight with a graduate student talk with Allegra Farrar. Thank you again for coming in. This is a series where we invite graduate students to expand on our exhibitions using their expertise in a similar subject matter as a way to see how art and research are overlapping on MIT's campus. Tonight, we'll be hearing from Allegra, a graduate researcher at MIT, working jointly in the Media Lab in the Department of Aeronautics and Astronautics with the Space-Enabled Research Group. Her work is shaped by the urgent need to address the inequities faced by coastal communities, where the impacts of tropical cyclones are often amplified by limited sensing infrastructure and growing climate uncertainty. In this talk, Allegra will guide attendees through the life cycle of a tropical cyclone, reframing hurricanes as essential planetary processes, Earth's own language of change. Drawing on her research, developing adaptive satellite observation strategies that listen to the shifting signals of the ocean and atmosphere, she examines how observation technologies can be used to embody particular values, extraction, control, or reciprocity. Connecting Octavia Butler's Earthseed to today's intensifying storm, this talk situates American artists' work within the lived urgency of reimagining both technology and community in relationship to the constancy of change. At the end, we'll have a Q&A where you'll have a chance to ask any questions you may have. Thank you so much for being here and showing interest in our programming. And I will hand it off now to Allegra. Thank you.
Thank you. Thank you, everyone, for coming today. All that you touch is change. All that you change changes you. The only lasting truth is change. This quote comes from Parable of the Sower, which was written in 1993 by Octavia Butler, whose work we'll be talking a lot about today. And Parable of the Sower is a story that travels or traverses a dystopian future, well, what was a future in 1993, from 2024 through 2027, in which a protagonist, Olamina, tries to find her way through a collapsing United States. Similar to Octavia Butler's work, American artist's work, whose installation surrounds us, speculates on this interplay of technology in society and how it impacts community. The art installation, more specifically, shows the link between Octavia Butler and American artists and their conjoined experiences of growing up in Pasadena, California. More specifically, what's behind me, which is known as the monophobic response, is a reimagining of the 1936 rocket engine testing that occurred in Pasadena, California through NASA's Jet Propulsion Laboratory. But it's restaged with telling through Octavia Butler enthusiasts, artists, and engineers, all working together to try and figure this technology out. So I invite you to take a look at the installations while I'm talking, and especially after this talk with the full audio and get the full immersive experience. A lot of this artwork definitely plays into some of the themes of the research that I'll be expressing today. But first, I would like to start with Octavia Butler's words herself. She was actually here back in 1998, and this was the period after Parable of the Sower was released and right as she was working on the follow-up novel, Parable of the Talents. And in her words, Parable of the Sower is a story of a young woman in a very grim near future who has assembled a new belief system, a new religion, and who believes in this is the answer. It's a future in which the United States has sort of gone in the direction of the Soviet Union. It hasn't been defeated by outside enemies. It's just sort of gotten very weary and collapsed. Funny, nobody ever thought that would happen to the Soviet Union until it did. That's kind of the framework of the story. She then goes on to say that the novel is, a central character in the novel is global warming. This is something that I really wanted to pay attention to, and it's odd how it went in and out of fashion while I was working on the novel. It would be very big and everyone would be talking about it, and then it would just kind of die, and then it would all of a sudden be big again. And I wonder about that. It seems to me that a thing as important as global warming should get a lot more attention than it does. So I portray a world in which global warming is doing things like creating a lot of erratic weather, severe storms, drought in California, and other things like that. And again, she says, this was not a book of prophecy. This was an if this goes on story. This is a cautionary tale, although people have told me it was a prophecy. All I have to say to that is I certainly hope not. So similar to Octavia Butler and American artists' work that surrounds us, this interplay between community, technology, and the environment are themes that I actively interrogate in my own research, studying tropical cyclones and the technical and social responses to them. Now for this talk, I will be referring to tropical cyclones as hurricanes. Within our region of the Atlantic Basin, we term tropical cyclones as hurricanes, but tropical cyclones is like an umbrella term for all of the chaotic weather events that stem from the equator. But before I tell you about hurricanes, I would like to invite everyone to take a breath with me, but I want you to breathe in, but not release it until I tell you. So everyone, take a breath and hold it. Keep holding it. Keep holding it. Okay, release. All right, how did that feel? Any thoughts? It's not a trick question, this is not a science question. I'm just curious. What are you feeling in your body? Tightness, yeah. Maybe an urge to get the air out. Yeah. So I invite you to just think about this moment, the physical response. I can't bring a hurricane to you and show you. That would actually be a very tragic event. But what I can do is sort of play on other sensory awarenesses of our own bodies to sort of give you an understanding of what our planet is trying to do when a hurricane happens. So let that sit in the back of your thought as I go through the rest of this talk. Okay, so most of our colloquial knowledge of hurricanes is usually the days leading up to impact. We see like the satellite images of these, clouds spiraling together. We see the roaring winds. We see the moments of impact. We hear the naming, the Instagram posts, thoughts and prayers, all of that coming together. But this is really just a snapshot of a small portion of these storms' life cycles. More specifically, these storms are a series of stages that are all working together as a coordinated attempt to redistribute the heat between our oceans and our atmosphere. But more specifically, these storms start quite well before the point of impact, close to the equator, and they start as these small disturbances known as tropical disturbances that occur within a thin layer where the atmosphere meets the ocean. And what allows for a tropical disturbance is when the ocean water begins to heat to a point that's warmer than the atmosphere above it. This is how we get evaporation. So this is the first instantiation of our planet trying to release some of that heat energy. But then what happens next is actually quite interesting and also quite uncertain. We go from these small disturbances where we're releasing some of this heat energy to a more coordinated environmental attempt from turning this to a disorganized occurrence to what is called a tropical disturbance. Now, what allows for a tropical disturbance is actually probably the most uncertain part of how a hurricane comes about, but yet the most important and impactful part about how we understand how storms make landfall. And the reason why it's so uncertain is because it requires, quite literally, just the right set of circumstances and just the right set of environmental circumstances coming together and working together to allow for this structured organization. Wind speeds from multiple layers of the atmosphere are working together, pushing air upward. There has to be the right amount of humidity, just the right amount of heat in the ocean, all these things working together. And there's no real telling that even if these things do exist, that a disturbance will turn into a depression. But if the engine is working together and we do get a depression, this storm can then continue to spiral and gain intensity, and then we get to the phase of a tropical storm. And at this point, this is where the storm gains a name, typically some news attention, and now hurricane specialists are starting to really pay attention and monitor the storm. And then if the engine continues to work with itself and continues to pump intensity into the system, then we get what is coined a hurricane. And hurricanes don't start as these massive Category 5 storms. They start with wind speeds of about 75 miles per hour. That's what denotes a Category 1 storm, and they increase from there. Ideally, not that much, but in many cases, they do. But the important thing to take away is that this entire system is powered by the release of heat, and it is an essential redistribution process for the buildup of heat within our oceans. But in recent years, what we see from these storms like Hurricane Helene, Milton, even most recently with Melissa and how it hit the island of Jamaica, is that we've seen these storms that challenge our systems of not just prediction, but of response. And not only that, but we are seeing that the changing and warming climate is not only causing these storms to grow stronger, but also become more distinct and more uncertain, and causing them to outpace the current observation and prediction frameworks that we have. And what data science tells us is that missed observations early in the storm is what allows for detrimental discrepancies at latter points in the storm. And because of this, when and how we collect data becomes extremely important, not just for understanding the science, but also for being able to provide actionable information that reduces the devastation. So right now, I'd like to call your attention to this poster. This is sort of an overview of the science missions that exist in space, most of which actually are covering Earth, but some of which covering other planetary bodies. The importance is not to see each of these directly, but to sort of get a general gist of what's out there. And even within some of the missions that are orbiting the Earth, within these missions, there's actually multiple satellites within these missions orbiting and getting a good view of our Earth system. And so you might think like, woo, yeah, we're doing great. We're able to observe our Earth. We're able to see what's happening. We're getting great views. The answer isn't necessarily yes, and the answer is not necessarily no. But what happens is that, one, climate change is causing our Earth system to require systems that adapt with that change. So fixed methods of observation are actually becoming a little bit more obsolete. And most importantly, a lot of these systems, in fact, actually majority of these systems, were not built with the community in mind. And what happens from there is that you get a lot of things that cause discrepancies in how we're able to observe these storms. One of which is that you get satellite missions that aren't considering the use cases on the ground and render themselves obsolete in moments of decision making. In addition, the data that's collected from these satellites and other observing systems are not necessarily considered with decision systems in mind, so the inputs don't necessarily yield outputs. And lastly, but most importantly, many of our communities in the global south that are most impacted by tropical cyclones or hurricanes, as I told you I was going to say, but that are most impacted by these storms lack a lot of the infrastructure for ground-based sensing that many of our forecasting systems rely on. And so what happens is you have discrepancies in the view of what's happening in our environment, and you have non-distinct pictures of what's happening in certain regions of the Earth. So as a result, myself, along with other members of Space Enabled that are here today, are developing space and environmental technologies where the community impact, which includes implications to policy, infrastructure, and sustainability, are considered central to the methods that we design. In the case of my work for hurricanes, I'm taking computational techniques that are actually typically used in robotics. And these techniques rely on an agent being able to learn and respond to its environment in real time. But I'm applying these techniques to satellite sensing. The goal here is actually to create a way for satellites to engage with the environment as it is changing during the storm's development. So instead of just passively collecting data and using predefined settings that are shaped by biased knowledge of what's happening in our environment, the system interprets what it's seeing in real time and then adjusts its sensing strategies to prioritize collecting relevant data. But that's not where the buck stops with the research. In addition to that, we are also partnering with scientists in these affected communities, specifically Puerto Rico, and co-developing the science priorities guiding this technology. So what that means concretely is that we are designing metrics that aren't just focused on the scientific understanding of early storm development, but we are also using information that matters the most to community planning. So for example, identifying wind and rain thresholds that are not just relevant for understanding the intensification of a hurricane, but that can also be relevant for things like agricultural planning. Do communities need to do early harvesting? How do power grids need to deal with loading of energy systems during the time of a storm? So in this way, the technology isn't just responding to the environment, it's also taking its cues from the community. But this crossover between community and environment and how it impacts the world around us isn't just relevant to hurricanes and natural disasters. I want us to take a moment and recognize where we're at. We're in a lovely art gallery that's sort of, giving us an opportunity to speculate on these topics, but we are also at an institution that is arguably the mecca of technological development. And while there's a lot of opportunity to engage with technological advancement, there's not as many opportunities to engage with the impacts of what that technology can do. And so some examples of this is that we're seeing an explosion of AI capabilities and techniques that can, further computational capabilities, but we're also seeing the increase of the data centers that are popping up in rural and in communities that are disadvantaged and pumping heat and contaminants into those communities. We're also seeing things like greenhouse gases exploding and pumping more heat into our oceans and our environment that are causing more explosions of hurricanes and storms and chaotic environmental events that make it hard for us to sustain ourselves in this day and age. And then not only that, but even just technology for observing our environment. Things like drone technology has been really useful in getting smaller scale views of our environment, but also very useful in surveilling communities against their will. All that you touch is change. All that you change changes you. The only lasting truth is change. I want to invite you all to breathe in again, but keep breathing. Don't let it out. Keep as much as you can. Obviously, don't hurt yourselves. I started this journey in graduate school without the intention of doing any environmental work. I was astonished by the ability to traverse the stars with technology and develop things that could take me beyond the atmosphere. But the more I learned and the more I engaged with the work that I was doing, the more I realized that it's important for me to recognize the impacts of the technology I'm developing and actively take a role in engaging how that technology impacts the world around me. I think we all have a role to play in some of the intense and violent releases that our environment has to make in order to have and be a functioning planet. Are you still breathing? Thank you.